Hi everyone again. Okay, so this is going to be, hopefully you guys will be able to hear the audio on this one. And if you can't hear any audio, then I hope you guys let me know, but we're going to try saving it in this format and see if that helps. Okay, so we left off on chapter 3 with some, what is heritable, what kind of traits are passed down. And so now we're going to talk about gene-environment interactions. And so how our genes are expressed, or how our genetic information becomes our phenotype or our observable characteristics, really depends on our environment. And so our environment kind of dictates or it influences what traits are expressed and which ones are not. And so the model that kind of goes along with this principle is the diathesis stress model. So the diathesis stress model kind of states that the likelihood of developing a disorder is a combination of both a genetic predisposition or a genetic vulnerability, so your inherited genetic material from your parents, from your ancestors, plus the experience of any type of stressors or negative life events. So it's not just that your genetics make you more likely to develop a disorder, or that your life, your stressful events in your life make you more likely to develop a disorder, but it's both of those together that really combine to form this likelihood of developing a condition or disorder. So this is in your book. So the diathesis, again, is a predisposition or a vulnerability. Usually it's genetically inherited. We really just think of this as kind of a genetic predisposition, plus any environmental stressors. So your diathesis is your genetics that you inherit, and then stress might be anything from trauma or stress or the prenatal environment. So the environment that you were developing in before you were born, any childhood events, childhood abuse, sexual or physical abuse, stressful life events, big life changes, that sort of thing can create stressors in your environment. And so those combined together kind of predict the likelihood of you or a certain individual developing a disorder. So the stronger the predisposition or the vulnerability at the diathesis is, the less stress it takes to produce the disorder. And so I'm going to give you guys a little bit of a better visual on the next slide. So here we have two representations of a tug-of-war game, and so we're going to focus on the top set of kids here. And so you'll notice that there's this red line. And so the red line here represents developing the disorder. And where the kids start, so where that flag is, represents the vulnerability of the diathesis. And so you'll notice up top, the first set of kids, that red flag is really, really close to the red line. And so we can say that this individual probably has a very strong genetic predisposition to developing a certain disorder. So then it doesn't really take much, right, for any stressful life events to kind of pull the already vulnerable individual over the threshold to develop the disorder. In contrast, in the bottom set of kids, we see that that flag is like very far away from the red line. And so comparatively, it takes more stress, more stressful life events, greater frequency of stressful life events to kind of pull that individual over the line to develop the disorder. So less stress, a greater disposition or vulnerability requires less stress to pull the individual over the threshold, and then a weaker or less genetic vulnerability, it takes more stress. So it's not necessarily that if someone has a genetic predisposition to a certain disorder that they will develop it. It really depends on how much stress is in their life. And someone who doesn't have a very strong genetic predisposition, if they experience enough stress in their life, they could also get pulled over that threshold. Okay, and now we're going to talk about some gene-environment correlations, which are going to be a part of the in-class activity. So first we have passive. And so these types of correlations are when you're not really doing much to affect how these correlations play out. They just kind of are. So your traits are reinforced by the environment that already exists. So say both of your parents are musicians, and so obviously you get that genetic material from them, so the musicality traits are passed on. But if they're both musicians, you might also grow up in a home where people are always playing instruments, are always playing music, listening to music. So growing up in that kind of environment, that correlates with your genetic material, but it's not something that you choose, right? It's just an environment that you're kind of passively in. Evocative gene-environment correlations are correlations where your predispositions, your traits, get other people to react to you or treat you in a certain way that affects your development. So if you are a very bubbly and cooing and babbling baby, you might have people interact with you a lot, smile at you, babble back, do a little baby talk. And so that's an evocative gene environment correlations because you're doing something that produces a social reaction in others. The last gene environment correlation is active. And so this comes more commonly when kids are a little older and can choose their own environments. So this is when your traits lead you to make active decisions about your environment, about your situation, about your behavior, that then in turn influences your development even more. So say that you come from a very athletic family, both of your parents were high school athletes and you're athletic. You might choose to participate in sports in high school. You might choose to go to a college where you can play club sports or play for your university. And so you're actively choosing your environment based on your genetic influences. And we all know reciprocal influences are very important. And so the genes that you have can affect your choices, and then your choices can affect the expression of those particular genes. And so we want to remember that all of these influences are pretty much all reciprocal. Okay, I'm going to touch briefly here on epigenetics. And so this is the kind of concept that environmental factors can chemically change our genotypes. So some examples. Identical twins may have slight variations in their genetic material and therefore their phenotypes based on womb conditions. So if you'll recall the twins that I mentioned previously, Ben and Zach, and so Zach is much taller than Ben, and so it's probably that Zach received more nutrition, more nutrients in the womb, and so the genetic material coding for his height made him taller, and then Ben did not receive that same kind of environment in the womb. So that's an example of how genetics can change based on environment. We also have a couple of rat studies. So we've seen that if rats are raised in a nurturing environment, it can actually alter their genetically programmed ways of responding to stress. And so if you take genetically predisposed stressed rats and have them raised by a calm rat mother, those rats in turn will manage stress in a calm way and then pass that trait down to their offspring. And the same we see in obesity. This is actually more prevalent in males. It's passed down in their genetic material. So if a father rat becomes obese, his genetic material is actually altered and his offspring are more likely to be obese as well as their offspring. If you'd like some more examples, I definitely recommend you guys check out table 3.6. It's on page 85 of the textbook, and it just gives you a little bit more examples about epigenetics. Of course, we do have to discuss the controversies of genetic research. And people ask the question, is genetic research valuable? Coming from kind of a biased standpoint as a researcher and a scientist, I would say yes. Genetic research has given us a lot of information about genetic disorders and diseases and abnormalities and helped us lessen the impact of these types of conditions. We also have to consider, though, the ethical implications of testing for genetic abnormalities and also altering genes through gene therapy. And it is controversy because we do know that there are pregnancies that are terminated due to genetic abnormalities of the fetus, and so that's an ethical debate. And also kind of the worry that we'll start, designing our children to be how we want them to be instead of how they would have been through random chance and you know, the gene selection that takes place during natural conception. And so these are kind of controversies that I won't get into in this class a little bit more, but they're interesting to think about, and we really should consider when we do genetic research. Okay, so here we have the class activity. Now I'm gonna kind of go over what I'm looking for in your guys' write-up and you know, what the activity is about. So in this first part, you're going to read both of these profiles. You're going to identify this particular individual's genetic predisposition or diathesis to developing the disorder that's mentioned. So for Dominique, it's substance use disorder, and for Ricky, it's major depressive disorder. So you're going to identify the genetic predisposition, where is it coming from? And then you're also going to look at the individual's environment. And I want you to give me some factors that might be stressful for the individual, and then other factors that might be protective or preventing an individual from developing that disorder, kind of tugging backwards on the tug of war, preventing them from crossing over that line. And then I want your guys' best judgment. There's no right or wrong answer. I'm not going to mark you down based on if you answer yes or no or maybe. How likely do you think the individual is to develop the disorder, and why? What I really want you guys to do is just to back up your answer. Make a good judgment and then tell me why you think that. For the second part of the in-class activity, what I'm looking for here is for you to read Anna's kind of profile from when she was a baby through high school. I want you guys to pick out which correlations are passive, evocative, and active. So I definitely go back to that slide with the gene environment correlations. Just recognize, you know, what is typical of each one, and then pull them out of the story. You can list them if you want. You don't have to write them in complete sentences. I just want to know which ones you guys believe are passive, evocative, and active. And so I want you guys to make sure that you put it on the same, you know, kind of in the same Word document. You can separate them by pages and turn it into Moodle before midnight tomorrow so that I can get them graded. And if you have any questions about the in-class activity that aren't answered here in the PowerPoint, please shoot me an email and I will get back to you with your answers.